This is Rubat Khan, and in this lecture, I'll try to explain the basics of recursion. Recursion is a very effective process of solving problems. Now, what sort of problems? Problems which have repetitions of a certain task or a rule. Recursion works by breaking down a problem into smaller pieces. And you can see on the slide it's mentioned the benefits of breaking down a problem into smaller fragments. That is, it's easier to solve smaller pieces of problems, and the solutions of the smaller problems can be joined to find the solution of the original task. Now let us look at this example, and I hope this will give you a better idea. For example, you're given a task of building a 4-storied building. Now what you do is you build one floor and give the rest of the building to be completed by another person, P. P does the same thing and passes the unbuilt portion to Q. And this continues until there's no more floor to build. Now each individual completed one floor, and eventually all the 4 floors were completed. Therefore you can see it was easier to build one floor, and building one floor, as I mentioned, one floor by one friend actually solved the original problem of building 4 floors. The question is, can you tell me which part of this task was repetitive? If we recall the definition of recursion, it was mentioned it was repeating a rule by itself. The building a 4-storied building was the actual task. Then the rule followed was building one floor and pass the rest of the floors to a friend, and this was repeated by all persons. And if you go in the first slide, it was mentioned by itself in the definition of recursion. By itself means this rule was forced within the task, not using loops. The recursion has 2 parts: recurrence equation and the base case, also known as a stopping condition. Build one floor, and if there are more floors to be built, pass the remaining to the next person. This is a recurrence equation, a rule that is repeated with the problem size decreasing at each step. Initially, the problem size was 4, and then at each step it was reduced by 1 until the problem was of size 1. Build one floor, and if there are no floors remaining, return it to the previous step or to the person who ordered it. So this is the base condition. This is also called the stopping condition, where I should stop my work. Now, whatever was explained in the previous slide was plain English. Now let us give this a more mathematical outlook. So let the task of building be build. I'm naming it build, and in the parameter n stands for the problem size, the problem, which is initially 4. Now we can rewrite the rule as if n is greater than 1, which means if there are more floors to be built, or I haven't reached to the last piece of the problem, then what I'll do is I'll do one floor and plus I'll build. Now if you see, I'm calling the build function again, and this time in the parameter I'm reducing the problem size by 1. This is the literal meaning of recursion, calling itself. I'm not using a loop. This is something repetitive. Instead of using a loop, I'm calling the build itself from the build function. And else, which means if n is equal to 1, when n is equal to 1, this is the smallest problem size which cannot be further broken. And when that situation comes, what I'll do is I'll complete one floor, and then I'll just return it and this time I'm not calling the build function. And use the command return 2 times, and this will be clear in the next slides. we've I'm quite sure you are quite familiar with methods so far, and I'm also quite sure you've looked at two types of methods basically. One is of type void, and the other is called a return type, where we return a value. Void methods uh, do not return any values. If you look at the method on the left hand side, there are three methods: met1, 2, and 3, and met2 is called from method met1, met3 is called from met2. Nowhere any value is returned. We're just calling the method. Now the question is, how does a program know that after completing met3, it must return to met2, not met1? And the answer is stack. Every method call is saved in stack. To be more precise, the values of the local variables, mathematical operations, and so on, everything are saved inside stack. Whenever a method is called, it is pushed in the stack. So according to the program on the left hand side, met1 is called first and met1 is pushed into the stack. If you look at the square, which is circled red, this has been pushed in the stack. And while pushed, the local variable x, the methods print, method call, met2, and print, these are all saved in the stack. First we print met1, and then we call met2 from met1, and then we pass the value of x, which is 1. When we call met2 is pushed in the stack, and that is circled by green. Similarly, we increase the value of y in met2 and then call met3, circled in blue. Whenever the execution of met3 is finished, it goes back at the end of met2. If you look at the red arrow, it goes exactly at line number 4, and then print y line will be executed, and then follow the next red arrow and it reaches the end of line number 5. And you remember, whenever a method has been completed, it is popped out of the stack. Now question, if a method call is a push, what statement invokes the pop? The answer is return. But if you look at the left hand side, the methods, there's nowhere I've mentioned the command return. This is because this is invisible. There's an invisible return command at the end of every method, and that return command does not return any value. Therefore, the developers made it easier for us not to write the word return every time when we are writing void methods. And try writing the command return at the end of void method like the one I did it in met1. Circle in blue, this is exactly the met1 on my left, but the only difference is I have included a command return. These two functions are exactly the same thing, will work exactly the same way. Now let us look at return type functions. Now how to know when to use a void method and when a return type method, and when to use a return type method. The answer is quite obvious. We need to look at whether method A or any method need a value or values to be completed by some other methods in order to fulfill method A's task. Look at the scenario below. In order to compute x, the second operand must be returned by method b. Question: should the method build in our building problem be of void or return type? If return type, what value is expected to be returned at the end of the method? On the left-hand side, we have the build method. Now we will look at how it works. For simplicity, let's say instead of building 4 floors, the task is to build 3 floors. We call the build method, and in the parameter we pass the problem. According to Recursion's equation, as n is greater than 1, I'll do 1 floor, which is marked green, and pass the remaining 2 floors to someone else. This is marked gray. Therefore, I must call the same build function on the remaining problem where n is equal to 2. So this is recursion. I am calling build inside build. As n is greater than 1, I'll do the same thing. I'll do 1 floor, which is marked green, and pass the remaining to the next person. As n is greater than 1, I move to the L section, and I do 1 floor, and then I return. I do not have anything more to build. I have hit the base case. I'll return this to the previous step, because this step is waiting for this portion. Now, these 2 portions are done. These 2 done pieces will be returned to the previous step, who was waiting for 2 pieces to be done. And finally, return the complete task to where the method was called. Finally, the build-end method. Now I'll give this method a proper Python syntax, and if you're using Java, you write this method in Java. So on the left hand side, I have the build function, and if n is greater than 1, I return 1 plus build n minus 1, because the problem size gets smaller by 1 at every step. Else I return just 1.